Hello and welcome to Small Lab, the situated multimedia arts learning lab. Today I will be presenting the titration scenario, which you can use in your chemistry classroom over the course of 3 days. The central learning goals for the titration scenario are to help students understand chemistry concepts related to titration and ionization, to connect students' physical lab experience with their understanding of chemical equations, and to help students go through an inquiry lab process. There are 4 main concepts to be taught here in the lab. The difference between acids and bases, the different ionization processes that occur, which include dissociation, ionization, and aqueous solution, the relationship between pH and the solution, as well as how to observe what happens when hydroxide molecules and hydronium molecules interact. Pretend that it's day 1 with your students in the chemistry lab. The first step in an inquiry lab process is that you want your students to be the key players in understanding and constructing the meaning and the model of the space. So you're going to ask the students to observe, and you're going to guide them to understand some of the most basic concepts. I just want you to take a look around at the space and tell me what you see. What do you observe here? What do you think this is about?
I see some molecules up here.
What about the molecules? Similarities between them?
Similar, they're all orange or pink.
They're all orange or pink, okay.
I think they're acids.
They are acids, great, yes. Do you see any similarities between these 3 molecules?
Oh, they all start with H?
That's right. Okay, so remember that. That's going to be a key point in understanding what an acid is, that there's that H in the beginning of the formula. And how about for the bases? This is a pH. Will be the pH number. You'll want students to also see that this number will play a role. Final thing is there's this really big open space here. And what do you think this could be?
At first I thought my feet would get wet. So it looks like water, but it's not water.
It's water.
It is water, but it's not real water.
It's not real water. This is our virtual lab. This is a virtual flask. And this is where we're going to be placing acid and base molecules.
That's like in the lab.
Just like in the lab, to create a solution. Once students have gotten a layout of the land here, then you'll want them to start putting molecules into the space. So Mina, why don't you go ahead and add a molecule, add an acid, and see what happens.
How do I put it in?
Just drop it down below. Oops. Okay, one more time.
Oh.
There you go. What happened there?
Yeah, that's kind of wild. It turned into 2 things. It started with 1 and it turned into 2. Yeah.
Okay, so when you added that one, the H2SO4, it turned into 3.
Yeah.
And this one, it turned into 2. Why don't you go ahead and try that as well?
This one might, should I make a prediction? I think this one will stay together.
Okay.
Not do anything. Wow, that turned into 2 also.
So it split as well. Okay, something's going on here. So as a teacher, what you can do to help facilitate this is that you can pause the scenario so that the molecules stop moving, and then zoom in to understand what just happened. So we're going to do a similar thing, which is just like we added each one of the acid molecules. We'll have the students try adding the bases and talk about what it is that they observe. Your students might notice, oh, well, when I add this NaOH, the sodium hydroxide, 2 molecules form. When I add the MgOH2, magnesium hydroxide, 3 molecules form. Now when I add this final one, 2 molecules form. The important part here, by the time the students get here, they should be able to see the differences and similarities between the bases. So they should understand that there is an OH, at least one OH, with each of these molecules, and that what happens here when they get added to the space, the Teacher, again, you can use the pause button in order to freeze the molecules. What the students should see is that for every OH, one of these large light blue molecules are formed. And what they'll see is that there is an OH and an OH, and then the conjugate part of the base, which is either the K, the Mg, or the Na. Key difference between the process of adding acids and the process of adding bases is that when the bases were formed, the molecules just broke apart in the water. They didn't pool a water molecule and bond with that in order to form a molecule. And that process of just breaking apart is called dissociation. That's very different from the process that the acids underwent, where the H stole a water molecule from the flask and created a hydronium ion. There's one more really important feature for this first day of lessons, which is the pH. We haven't talked about that yet, and the students, once they've had the opportunity and you've had them cycle through, all of them cycle through in order to place molecules in the space, it's probably a good time to have them take a look at what's been happening with this number, which is the pH. So right now, there are bases here in the solution, and the students may have noticed that the number is higher than it used to be. We can verify that for them, which is to empty out the solution and see that this neutral flask of water originally had a pH of 7.0. Whenever a base gets added, the pH begins to go up, and that essentially this solution is becoming more basic. From that, you might want to ask students if they could hypothesize what would happen if you added acid instead of bases to the solution.